All right, welcome everybody. I'm going to give folks a few moments to join, and then we'll do a quick intro before we jump into today's CEU course on insulated metal wall panels. Today's course is presented by ATAS International. We've got RC on today who's going to be giving our presentation, and Jason is also on standby for the end if we've got any questions that come up that could use his input. So very excited to be bringing you today's course. All right, looks like we've got a good amount of folks jumping in. So I'm going to go ahead and start off with a quick intro, show you guys some things to check out after today's webinar if you're looking for some more information, as well as a little bit of housekeeping items, what to expect about credits and all of that good stuff. If you don't mind, RC, I am going to take over the screen share momentarily, just FYI.
No problem.
All right, cool. So awesome. Can everybody see my screen okay? Great. All right. So thank you everyone for joining today. Today's course we're bringing to you from the team at Acelab. We're helping out with hosting today's event. So if you haven't checked out Acelab's platform, feel free to head here after today's webinar. This is a great place to come to get some more information about the products and the items that we're covering today, as well as get in touch with today's course presenters directly. So there's a ton of free resources and tools here. I will drop my colleague's meeting link in the chat so you can set up some time for a free demo if you're interested. But today, just want to show you what to do if you know exactly who you're looking for. So Acelab hosts data from building product manufacturers. We've got search categories that you can take a more guided search. But if you know exactly who you're looking for, you can always use this search bar in the top here. Type in the name of any manufacturer. It'll start to auto-populate and it'll cross-check between product categories or different manufacturers. And then you can just click to head over to their page on Acelab. This is a great place to come after today's webinar if you're interested in learning some more about ATAS's products specifically. You can also use this contact button to get in touch with their team if you have some follow-up questions or you want to discuss a project with them. Down here, you can explore some more about their company. And then over here, you can view all of their amazing products. You can save these to your projects. And you can also open up any of these pages to access downloads, CAD files, spec files, as well as view some performance information, finish options, all of that good stuff. So I'll drop a link to this page into the chat as well for easy access, but this is a great place to come after today's webinar. Another quick thing I just want to show folks in case you are interested, we do have some newer features that we have started to launch for architects on Acelab. So jumping over here to one of my projects on Acelab. Over here on the top right, you've got kind of your stuff on Acelab. So your projects, your conversations, your firm library. If you're looking to get some help in kind of getting this all set up, our team is happy to help you. You can feel free to book some time with us and we'll get all of your projects and your firm library onboarded. So we have recently released a schedules feature. This is a newer feature that is currently available to beta users who are part of our early access program. So anyone who's on today's webinar is invited to join that early access program. I'll send over some information about getting that set up. And our team will help you build this out for your projects and for your firm library. Basically, it's a really great place to store all of your product information along with your reps. You can bring in Acelab's data points, which really saves a lot of time. And then you can also include any number of custom data points. So approval statuses, tagging with different assemblies, adding notes about which finish options you like. This is fully collaborative, so your whole team can access it. And it's a really great way to make sure that you're storing all of your product information and making sure it's really accessible and works for your team. So if this is interesting to you, if you want to explore it a little bit more, feel free to set up some time with my colleague that I'll send over in the chat, and we'll help you get onboarded. All right. Other than that, I just want to go over a few quick housekeeping items. Today's course is CEU approved. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily if you're worried you didn't include your AIA number yet, or if you would like to request a certificate specifically. If you have been to a webinar with us before and you filled out that form in the past, you don't need to do it again. Your information does save, so we'll have that. But just in case you haven't been and you want to make sure we've got that info. Other than that, just want to really encourage folks to please ask any questions throughout today's presentation in the Q&A. We'll keep our eye on those. We should have some time to get to some live. If we don't get to your question live, we'll have the ability to follow up with you after today's webinar. All right, that's all for me. Thank you all so much for joining again. And RC, whenever you're ready, feel free to go ahead and get started.
Okay, perfect. Thank you so much. This is RC Antal with ATAS International. ATAS is Director of Insulated Metal Panels here at ATAS, based out of our Allentown, Pennsylvania location. So for our presentation today is Insulated Metal Panels, creating the perfect all-in-one barrier backup system. Now, a little history about ATAS and some of the products that we offer. So ATAS stands for Aluminum Trims and Shapes, and was started back in the late 1960s by Jack Buss there, in the family's Rochester home. Now, since then, over the past 60 years, the business has significantly grown. We have four locations: Allentown, Pennsylvania, Mesa, Arizona, University Park, and then also our sister company, which is Brightsmith Coil Coaters.
Real quick, RC, if I don't know if you mean to be screen sharing right now, but I just wanted to check your screen isn't shared, just in case that was meant to do.
Sorry, here, give me 1 second here.
All good.
There we go. Thank you so much.
There we go.
Sorry about that, everyone, and thank you both for jumping in there. Continuing forward, ATAS has been around for over 60 years, and we are currently transitioning from second to third generation. So it has been family-owned business since the beginning, and ATAS is continuing that way into the future. Now, a little bit about the products that we do offer. So it all started 60 years ago with our trims, but has since then grown into metal wall panels. And to give you an idea of some of our breadth of wall panels that we offer, we have concealed fastened wall panels, modular panels, exposed fastened panels, MCM and plate systems, to name a few. We also get into perforated metal, and we can do that from a design standpoint or also a functional standpoint. So a wide variety of perforation options. We also have a wide variety of metal roofing, including standing seam designs, batten seam, shingles, tile systems, and even through fastened systems. So a wide variety of single skin metal roofing systems. We also get into curved and taper panels. We can do that on both walls and roofs. We get into custom fabricated panels, and this is something I wanted to highlight. If you go to atas.com, we actually have an area that we just launched about a week ago where you can actually upload your design concepts. They can be reviewed by ATAS, and we could potentially make a custom panel just for your project. We get into a lot of column covers, of course, the insulated metal panels, which we'll be discussing today. And a new area that continues to grow is our interiors, our ceilings, and our soffits. One unique thing about ATAS is we use all PVDF paint finishes that you would see normal in the exterior of the building, but we also continue through with that quality on the interior of the building. We also offer perimeter edge systems that would be anti-spray and also ES1 tested. We also have architectural accents like mitered corners and factory form corners and trimless ends. And of course, a wide variety of accessories from snow guards, rainwear systems, everything needed for proper installation of any of the insulated panels that we sell, single skin panels and metal roofing panels. So a wide variety of accessories. And then also light gauge framing accessories, hat channels, continuous insulation girts. All those materials are available through ATAS as well. A little more about our website. This is a great resource for everything that we offer. We have our spec information, our CAD designs. We even offer BIM modeling. So anything related to any of the products, it could be a gallery information about different applications, all the information for load tables, Florida product approvals, or other testing. Well, all this information can be found on the website. One thing, if you would like to get in contact with ATAS, there is an area where you can go find your local product representative, and someone will give you a call to assist you in any type of questions that you have or design of the project. Now let's get started. So today's presentation is insulated metal panels and creating the perfect all-in-one barrier backup system. So if you're familiar with an insulated metal panel, that can be a finished completed wall assembly, but a barrier backup system takes it a little further, and we'll show you that today. Of course, the presentation is AIA accredited and also GVCI, and Bill will be taking care of those credits and sending the information out after the presentation. So our learning objectives for today, we are going to recognize the key elements of a perfect wall. There's multiple types of materials that are used out there to create a perfect wall, and we're going to explain a little bit about each of the different types of construction, and then ultimately get into what the barrier backup systems are. We're going to identify the different types of wall assemblies and the efficiencies of them. Each wall assembly has its, benefits and features, and then also, areas that we have to be aware of, as far as longevity. We will review the different components of the barrier backup system and talk about all the performance associated with it. We will dive into the insulated metal panels specifically to talk about how they work and how they are installed. And then, of course, we will finish the presentation up with going over some of the lead attributes and the credits that you can get with using an insulated metal panel barrier backup system. So we'll dive right into it. But first, we have to start with building science. We have to create the perfect wall. So when we look back in history, that perfect wall, it was rocks. Man used rocks to create a wall to keep the environmental on the outside. And that's what a wall is. We are trying to keep the exterior on the exterior, the inside on the inside. In summary, it's an environmental separator. Now, since the beginning of time when, humans first used rocks, how buildings were designed and developed have significantly changed. And the types of materials that we're using, a lot of synthetic materials that are used in wall assemblies to increase the overall performance of the wall, the breathability of the wall, also the thermal performance of the wall. But in the end, all walls have multiple components there to create that perfect wall. And we'll show you some examples of that. So for a perfect wall, there's four principal control layers. And here they are in order of an importance. We have rain control, air control, vapor, and of course the thermal control. Now, one thing to keep in mind that these are in order of importance. So for example, if we can't keep the rain out of the wall assembly, we're not going to be able to control the air or control the vapor or the thermal performance. For example, if you had, you can control the rain side, but you can control the air side, but you can't control the vapor side. So once again, we have to be able to have all of these control layers in the wall assembly to create that perfect wall. Now, these control layers are done to protect the structure, and that's why they are on the outside of the building there, because ultimately we have to protect the structure. Now, there's a couple areas of compromise that can, hurt or harm the wall assembly and the structure. And that could be, corrosion, ultraviolet's very tough on buildings, expansion and contraction. A lot of it is related to heat on the building. So those control layers are put in place to protect the structure. And that's what we're going to talk about today. Several different types of wall types and lead us into what the barrier backup system is. Now, with all perfect walls, there is different types of construction. So for example, we would have like an institutional, commercial, and a residential. And when you get into your different wall types, like an institutional wall, that could be a art museum, that could be a college campus, that could be a governmental facility, a type of building that's designed to last, say, hundreds of years. The type of construction and the materials that will be used, in order to achieve that perfect wall assembly over hundreds of years will be very robust, expensive, often heavy, very durable. However, if we were to apply those exact materials to, say, a residential wall, the average home might not be affordable. So regardless of the type of application, there's different materials out there that you can still have those four primary control layers within a wall. And that's what we'll be looking at today. Now, the basic wall types, this is a little bit of review of the different type of walls that we will see out there in, commercial, institutional, and industrial construction. We have barrier walls, mass storage walls. Then you get into your insulated metal panels, and then also your insulated metal panel barrier backup systems. And these are the different systems that we're going to talk about. The biggest thing with all of these wall types is that water management. That is absolutely critical. Without being able to maintain water management, we can't have a durable, long-lasting wall. When it comes to water management, there's several areas that wall assembly can be compromised. You can just have, rain with gravity, wind-driven rain, or surface tension. And one of the hardest to control is pressure differentials within the building. So the ideal perfect wall would be able to protect the structure against all of these areas of compromise. The first type of wall that we see, which is very common, is a barrier wall. This is often a storefront or a glass and glazing wall, curtain walls, also as a pre-engineered metal building. As far as the features and benefits, aesthetically pleasing, they look nice, they're open, they're a single element, and they're relatively easy to install. However, it is critical that the installation is perfect. A lot of these systems rely on gaskets and sealants. We show an example there of, sealants that have degraded over time. And while these systems, are very aesthetically pleasing, when there is a compromise in there, often by the time it's noticed that there is damage, it's already too late and water infiltration has already occurred into the building. So, a very common wall that we see out there, but, that there's, features and benefits of it, but we have to be careful that these materials are installed properly and that the maintenance, the seals and gaskets used are intact and don't degrade over time. Another type of very common wall assembly that we see, especially with large distribution centers, would be, mass storage walls, which would be considered concrete tilt up or block or precast. Now, these types of walls are very durable and very long lasting. Really good for fire resistance there. They are certainly non-combustible walls. However, the creation of the walls, the foundations have to be very strong and solid because of the panels are how heavy they are. Also, weather considerations when these buildings are being installed, as well as sealants with the use of them. So while they're very durable and long lasting, there's some maintenance that has to be done with them. The construction is important. We have exposed sealants there that will need to be maintained. And then the overall aesthetics. A lot of times these are distribution centers and, you might find a large, couple 100,000 square foot building that is a single color or maybe one or two colors. And that's really limited to, the exterior there. So from an architectural standpoint, having them blend in with the surrounding environments is, often difficult. The next type of system, which is very common and one of the most widely used because of its performance, is a Rainscreen system. Now, a Rainscreen system is, a moldable component system there that creates that perfect wall. But on the exterior, you often have metal panels, brick veneering, terracotta, and MCM composite materials. Now, these robust systems are moldable component and are adaptive to using moldable materials. Like I said, brick can be one, MCM panels, single skin metal panels. In today's markets where we're seeing, a wide variety of mixed usage, Rainscreens can be adaptive to use a wide variety of exterior Rainscreen materials. Some of the difficulty that we often see is availability of materials when we're getting into, an 8 to 9 different component assembly there. If a contractor is potentially trying to make a change and a substitution request, and then also the installation of these systems there often require multiple equipment on site, multiple trades. So it makes it for a little bit harder to manage, but yet a very durable, long lasting, widely used system is the Rainscreen systems. Now with Rainscreens, there are two different types. The most common would be your drained and back ventilated. Rainscreen that is going to have your air, water, and vapor and thermal elements all built into there, protecting the structure. But one area that it is difficult, area compromise, would be that pressure differentials. A drain and back ventilated system does not do that. Water that enters into behind the exterior rain screen will be filtered and drained out through the bottom of the system. Now, your pressure equalized rain screen systems are even more robust than your traditional drained and back ventilated rain screen. These systems often require project-specific engineering, and the installation and the design of these are going to be very critical. So we will see a lot of additional project-specific engineering associated with them, but very effective against all of those areas of compromise. Another type of wall system will be the insulated metal panels. And where these are different compared to a rain screen they are a single component and they are an absolute barrier. They are not a rain screen. They're a single component. They're less complex, making for fast installation. You have your exterior finished. You have your vapor and air barriers that are built into it, and then also your thermal performance. So it allows for fast dry-in times. However, with insulated metal panels, profiles can often be relatively flat or lightly profiled. You usually won't see real drastic pleats or corrugations with these panels. And then also when you get into color options and other design options, sometimes it can be a little bit of a limit there versus, a wide variety of colors. Might have a smaller color palette there. Next would be the IMP barrier backup system. We're going to take all the components of the insulated metal panel, and then we're going to add an exterior, quote unquote, a rain screen portion to it. So while the insulated metal panels are an absolute barrier, by adding the additional layer of, say, single skin metal in there, we can add that architectural element or mixed use products there, which is providing even more protection over the insulated metal panels, which are already a perfect barrier there. And we do that through the insulated panel, the exterior, say, single skin metal panels, and then some simplified hat channels or Zs. And we'll show you some more examples. Because the insulated metal panels of the barrier backup system there is an absolute barrier, they provide the areas of compromise that pressure differentials. Insulated metal panels are pressure equalized. So they allow for that perfect wall assembly in a single component IMP panel. Because the insulated metal panels go up with a fast speed, up to about 5,000 square feet of panels per day, it will allow the building to dry in much faster. Also, because there's not multiple components, it does allow for a single trade, which makes job site performance and organizing much simpler. Here's an example of a project. This is Colonial Middle School in Plymouth Meeting, Pennsylvania. The entire building was cladded with insulated metal panels that went around on all sides. This was an entire barrier backup system. One of the benefits of the barrier backup system, besides being able to dry the building in quickly with the insulated metal panel acting as your vapor and air barriers and your thermal performance there, and also your weather tight barrier, from there you can add those architectural elements. And you will see we have the exterior brick that's being put on. The brick ties would go into the building, fasten through, and go back to the structure. And then the brick can be installed. And then you'll see as this building grows, the other materials that are used. So since this is a single source, especially when we see times during COVID times when so many materials were on back order or not available, with insulated metal panels, you're reducing your moldable components into a single panel. That would give you, less field installed components. Managing, work crews, you have one trade. There's not multiple trades on site. And as far as equipment, because there's not multiple trades, there's not as much equipment and as much organizing. It makes it easier for the general contractor to control it. And also, reviewing the quality of the install. You're not monitoring multiple trades. Now here's the building after it was completely finished. So all sides of the building were completely weather tight by the insulated metal panel. We have the brick facade on the exterior, incorporated by several different types of single skin profiles and colors. You can see the wall cladding there in the silver areas, but different profiles, the eyebrow details, and then on the far right, MCM panels that were also incorporated. But behind that is all the barrier backup. So providing that weather tight, perfect wall, high performing with the R value there, and then with the secondary layer, all the aesthetics of the building. Now, when we talked about the water management being absolutely critical to protecting the structure, these were the areas of compromise that could affect the building. And like I said, the insulated metal panels provide, that pressure equalizing panel interlocks there. So they truly do create that perfect wall. Now that you have a general understanding of different wall types and assemblies out there, let's take a look at the components that make up the barrier backup system. And at the heart of that is the insulated metal panel. And the insulated metal panel consists of an exterior facer skin, an interior liner skin, and it's sandwiched together with a polyisocyanure foam core. It provides the finished exterior if left exposed, the vapor and air barriers, and also that thermal performance. And I'll show you how that does that. Now, a little bit how the materials are made. So these panels are typically made on a continuously moving line that consists of a facer sheet and a liner sheet. That sheet metal is roll formed, and it goes through a foaming area where it is a liquid foam, polyisocyanurate, that is poured in place. It goes through that heating curing chamber, which is also known as a double belt. And from there, the panels are actually cut, stacked, cooled, and packaged, and then they are shipped to the job site there. Excellent for quality and also the speed of production there, which helps control associated costs. Once again, the IMP is taking all of the items and putting it into a single component versus multiple separate components. At the core of that is that polyisocyanurate foam core, which is boosting R values up to an R8 per inch, which allows for a thinner wall assembly at a higher R value versus traditional components. Also, the foams that have been used are all zero ozone depleting. Why the actual panels, the materials used with the insulated panels has changed over time. The concept of the panels hasn't changed since the introduction, back in the late 1960s. That's how long insulated metal panels have been around. Now, insulated panels can be used as, the completed wall assembly. I showed you that earlier in the presentation. But when we're doing a barrier backup, there's going to be a couple little differences. Usually it's going to be just a lightly profiled panel there, what we will call like a mesa type profile that adds some stiffening to the panel. We would use a little bit lighter gauges than, say, if the panels were going to be left exposed indefinitely. So you would most commonly see 26 gauge on both sides. Some manufacturers might even use like a 29 gauge. And the paint finishes. In the industry of metal, you would normally see like a Kynar or a Hylar paint finish, would also be known as a PVDF paint finish. But because the panels are not going to be exposed, for the lifetime of the building, we would typically use a siliconized polyester or a polyester paint finish, which would help control cost. Now, unlike some exterior gypsums, which maybe can be exposed on the job site, exposed to the element for about 6 months, these barrier backup panels are finished panels. When they're being installed, why the design around them is not for aesthetic purposes, it is strictly for function. Those panels can stay exposed forever. They are designed to do that. They don't need another layer on top of them. So, if there was a construction delay, or say there was a retrofit and the single skin panels were going to be removed, this dried in wall assembly could stay exposed indefinitely. That's one of the huge benefits with the barrier backup systems. Panels are typically available from 2 to 6 inches. Like I said, R values of boosting R values up to an R8 per inch there. So very thermally efficient. Panels are typically 3.5 feet wide, and panels can run up to 53 foot. Some manufacturers can actually produce the panels longer, but trucking considerations need to be taken into account. So with insulated panels, when you're installing them, it's not common to see these barrier backup systems being installed about 5,000 square feet per day. That's going to allow the contractor to quickly dry in the building. And once that building's dried in, the general contractor will be able to not only work on the interior of the building, but also on the exterior. And this is very beneficial, especially in those winter months. Instead of having draped plastic and auxiliary heaters, when the building's already dried in with the insulated metal panel, crews can continue working. Now, one very important aspect is the components are the accessories that go with the insulated metal panels. There are sealants involved with insulated metal panels. Of course, your fasteners and your panel clips there. Some framing, usually half channels would be needed. And then in some considerations, you may have some above sheeting ventilation shims. So the manufacturer that you're working with would be able to supply all of these items. And it's always recommended that you would get the accessories from the manufacturer. After all, we are going to provide the materials that are best suited for your building and the materials that are being used. And then the last part of the barrier backup is the exterior facade there, which we're calling our Rainscreen options. And while they are providing Rainscreen protection, even though the insulated panels don't do that, they are providing that secondary level of protection, but also really the design element, where with single skin metal panels, a lot more design, a lot more color options. But that barrier backup can also incorporate MCM, brick veneering, terracotta, along with other systems, which makes it very, very flexible in design, especially with buildings that, the architect is looking to use a wide variety of materials, to match the surrounding or really make the building a focal point. Now, a little bit about the performance of insulated metal panels and the barrier backup system. One of the biggest performance benefits is the thermal properties. I had talked about R values up to an R8. So if you have, say, like a 2.5-inch panel, you can boost an R value up to about an R20. When you look at compared to other traditional assemblies, whether it's draped insulation or exterior foam boards, insulated metal panels are fully encapsulated and help boost some of the highest R values. The benefit of having that high R value is, properly conditioning that building. A lot of wear and tear is associated with the HVAC systems. Those systems are very costly to repair and replace if they're not well maintained or if they're overworking. So by having a building that is properly insulated is really going to help overall save energy cost and then also maintenance costs on those systems. Furthermore, building occupancy, the comfort levels of the individuals inside the building. When you have a properly insulated building, you're going to have much more controlled thermals throughout the building and, not hot and cold spots. So it always pays to insulate. When it comes to the insulated metal panels, like I said, they are fully encapsulated there, boosting some of the highest R values in thinner assemblies. So when you're looking at products, on a per inch basis, insulated metal panels really excel in those values there. Overall, when you can use a thinner material, but still get the R value that you're looking for, you can have an overall lighter structure that's easier and faster to install. Insulated metal panels also contribute to continuous insulation under ASHRAE 90.1 there. And I'll show you an example of that. When we have traditional building systems, where we might say you have like on a pre-engineered metal building, like a draped insulation there, anywhere you compress insulation, you're going to lose R value. And let's say your overall design R value of the building is say an R20 there. In the areas where it's compressed, you're going to lose R value, which could affect the overall performance of the building. When you're using a insulated metal panel that's going on the outside of the structure there. It's not being compressed. It's much easier to hit the designed R value over the entire structure because of the continuous insulation properties of insulated metal panels. Now, besides the thermal performance, it's very critical is the continuous air barrier. And insulated metal panels do that in two different ways. When the panels are being installed, we have to protect against any type of air or vapor drive between the structure and the panel. So the use of non-skinning butyl sealants are applied to the structure, and then the insulated metal panel is installed. Now, a question that comes up, what sealants are used? It would be a non-skinning butyl. And a lot of questions I get, okay, is that an area of compromise? A lot of times sealants can, break down over time. Well, non-skinning butyl never fully sets, cures, or fully dries. And with, like all sealants, UV can affect it. Well, with insulated metal panels, all the sealants that are used are not exposed to UV. It's all concealed between the frame of the building and the panel, and also in the panel interlock. With insulated metal panels, there should never be any exposed sealants when it comes to the vapor and air barrier. All of those are designed to be concealed within the panel or within the frame of the building. So once the building's picture framed and the panels are starting to be put up over the frame, the sealant locations also include the panel interlock there. Now I'm showing the sealant in both locations there. Typically, the sealant would have to be used on the interior side, which would be the vapor barrier side, but it's always a best practice to provide sealant in both locations. You're also going to provide it in the pigtail location, which would incorporate where the sealant is between the frame of the building, the IMP panel, in that interlock, and the continuity of all three locations. When we do that, the building is virtually airtight. So we can truly make an airtight building when properly installed. So besides our thermal performance, we're getting that continuous vapor and air barrier of the panels. And this is why they are absolute barriers that do not allow any water or moisture into the assembly. You can also see the panels are thermally broken at the interlock there, where we have the facer and liner skins. And in between that, you can see that thermally broken area. The only thermal bridge that we have would be with the fasteners. And under ASHRAE 90.1, the fasteners are accounted and accepted for that. You can see an example of the structure with all the insulated metal panels fully installed. You can see here, the panels are being installed horizontally. And once again, that insulated metal panel provides all of those control layers. So we have your exterior rain barrier, we have our vapor and air barrier, and then also our thermal performance on there. So in this picture, if all the windows were properly installed and flashed, that building would be 100% weather tight and could be left exposed like that until the exterior, facades are put on. And then last but not least, that exterior facade that we talked about, the exterior Rainscreen portion of the system there, really driving the aesthetic performance. That's what that really highlights is the aesthetic performance. But then also, because those exterior metal panels or terracotta or other systems, they are also providing an additional level of prevention of water from even touching the insulated metal panel. When it does, get behind, say, the single skin metal panel, it would just drain out at the base. And if any type of water or moisture does touch that insulated metal panel, once again, that is a perfect barrier, and any type of water or moisture would not proceed into the building. The insulated metal panel would block that 100%. Now let's take a look at it, the system as a complete whole here. So when we get into, those common Rainscreen systems that are used because they're so robust and long lasting. However, we have multiple components here. So we have our exterior Rainscreen element, rigid insulation subframing, our air and water barriers, say some exterior gypsum, and your finished interior there. So we have, 8 to 9 different components. And when we're getting into the barrier backup, we're going to be eliminating the majority of those because the insulated panel is going to be that thermal and vapor and air control. And that's what the insulated metal panel does. It takes all of these areas that we need for the perfect wall and puts it into a single component. And once again, because it is a single component, it allows for faster insulation, better weather tightness, and ease of construction. It allows for faster construction. Now, when designing with a barrier backup system, there is some considerations that take place. And we can take that 8 to 9 different component system and turn it into approximately 5 different components. We would have those architectural, say, Rainscreen panels or hat channels, that insulated metal panel, which is providing that vapor and air barrier and thermal performance. And then, of course, your interior primary structure, along with, say, interior gypsum if you're finishing the inside of the building. Now, the design considerations. So when looking to use a barrier backup system, you have to pre-plan a couple things. If the building's going to have, say, vertical main framing, so vertical studs there, the insulated metal panels would typically be installed horizontally. Now, IMPs can be installed bidirectionally, so vertical or horizontal installation is not a problem. But the goal is to reduce the amount of additional subframing that we need. So we can see here, primary framing is vertical, the IMPs are being installed horizontally, and then we would have the hat channels, and the hat channels would be installed in a direction in accordance with the framing, and then also the Rainscreen element that's going to be installed afterwards. So these are all areas of consideration. One thing that I would like to highlight, when those hat channels are placed into the building, they actually fasten through the panel and they fasten back to the structure. In all locations, the structure is always going to bear the weight of the IMP panel and also that single skin metal panel. These single skin metal panels with those hat channels are not fastened just to the IMP. They actually fasten through it back to the structure. And appropriate screws with washers, and then also butyl tape or butyl sealant would be used that would prevent any type of water infiltration at those fastener locations. So here's an example of the barrier backup system using the horizontal Rainscreen panels. We have our main framing, which is vertical. We have the IMPs installed horizontally. And then from there, because we want to install the Rainscreen panels horizontally, we would just simply put the hat channels vertically, which would allow for that horizontal Rainscreen installment. Now, this is where it changed a little bit. You can see on this particular building, we would have, say, horizontal girts. We can see that the IMP panels, which have excellent spanning capabilities that can span 4, 5, 6, 7. In some areas, I've seen panels span up to 10 feet in between supports there. But the IMP panels will be installed vertically. And because the Rainscreen panels are going to be installed horizontally, once again, the hat channels will be installed vertically. Now, where this changes is if we were to use this example, but we wanted to install those Rainscreen panels vertically, we would most likely in this application need some additional subframing. So you would have your primary purlins there, vertical IMPs, you would have vertical hat channels, then you would need some horizontal hat channels to run that single skin panels vertically. So keep in mind the orientation that you want to run your exterior Rainscreen there. And by pre-planning that, you can often reduce the amount of subframing that is needed. Now in review here, the total system performance of a barrier backup system. The IMPs are taking care of that single component, the air, the vapor, the water, and the thermal barriers. The insulated metal panels are an absolute barrier. The exterior Rainscreen portion of it is providing the aesthetics and also additional weather protection on the building. High R value is up to an R8 per system. I want to highlight down on the lower right-hand corner, this is terracotta, but this could apply to like a plate system. You can see with the panel orientation and the type of Rainscreen that's being used on the exterior, some additional subframing is required, and you can see that. A lot of the subframing would typically be like a light 18 gauge galvanized hat channel. Here's some installation pictures. The IMP barrier backup panels in, the windows are installed. That lower brick is installed using brick ties, just like it would on a traditional wall assembly. But now those hat channels are being installed, which would allow installation of the Rainscreen panels. With the barrier backup system, we have fewer field assembled components there, which allows for a quicker installation. And, let's say the building was being rented and there was a new tenant that wanted to change that exterior facade. That exterior facade could be completely removed and then exposed in the IMP panels. But because the IMP panels are a perfect barrier there, they could be left exposed indefinitely, which allows for, future change out. You can see the Rainscreen panels that are being installed vertically. This building had a vertical metal studs there. The IMP panels are running horizontally. The hat channels are running horizontally to account for this vertical insulated metal panels. Also, with the flexibility of the system, you're not limited to one exterior facade. You can incorporate multiple mixed products, including brick, including MCM panels, terracotta, also single skin metal panels, and all those materials could be used on one building combined, as you've seen in some of the previous pictures there. The insulated metal panels, like I said, have been around for about 60 years. And why the concept of the panels haven't changed much. Certainly the materials and components. When it comes to applicable fire standards, FM 4880, NFPA 285, ESTM E84, the IMP panels are class 1, class A panels. And when you would look at like the single skin materials, the single skin would all be non-combustible. Once again, in all areas of the building here, all have insulated metal panels behind it. You can see there's a lot of brick, there's a lot of MCM panels, and certainly a lot of single skin panels. Also areas where they're adding soffits to the panels. So a lot of design on architectural elements in the building, but very, very thermally efficient building. So in review here, how does a barrier backup system affect the different levels of the construction? So let's look at the architect. Single component, you can work with a single manufacturer. If you were doing a true barrier backup and single skin system, you could work with truly one manufacturer. That would be one set of engineering, one set of shop drawings. It would be a simplified performance. You would be giving the building owner a high performing building with less involvement of multiple trades there. That comes especially flexible when contractors like to use certain materials, and if they're trying to do substitution or change requests there, you have to ensure that those substituted materials still meet the performance requirements of the entire system. Well, with the barrier backup system, you're eliminating a lot of that. This system is also very architectural flexibility, allowing you to use a wide variety of materials. For the building owner, much faster construction times, especially if it's a retail outlet or a distribution there. The building can be erected and dried in much faster. With the thermal performance of the insulated metal panels, exceptional energy performance and energy savings, a lot less wear and tear on the HVAC equipment, saving overall cost and resources. And once again, that architectural element that the building owner can get. They can change facades out in the future, or if they ever, lease or rent it, they would be able to change it to accommodate the new tenant's needs. From a general contractor standpoint, they can keep the construction cycle going. There's less trades on site, less coordination, less equipment on site there. And also working when the general contractor is working with the architect and the building owner. It's just a much simplified process that's quicker to achieve because of the single components associated with it. Insulated metal panels can also be incorporated with other systems. For example, a transpired solar collector, where the overall concept is very much like that barrier backup. You would have an insulated metal panel. You would have an exterior single skin metal panel, which would have micro perforations on it. That wall cavity would heat up, and then you could use a fan system that could bring that air into the building or bring that warmed air into the HVAC system preheated, and then the HVAC can finish it. And I'll show you an example of that. Here's those precision lance micro perforations, which would allow air into that wall assembly. Now, keep in mind, you have that IMP panel, which is that perfect barrier there. So this warm air that's being pulled and trapped in the assembly is on the outside of the building envelope. Here's an example of the system, how it would look once it's installed. You have your IMP panels, you have your various subframing, and then that single skin panel, the collectors would go over on this. And I'll give you a real world example. On the particular building that you see here, there's test data that shows, exterior temperature was about 32 degrees. The interior temperature of the warehouse was about 55. And this system in that wall chamber there was generating warm air of about 75 degrees. So something where it's a warehouse, a lot of air transfer, a lot of opening up, a lot of garage doors, trying to maintain a reasonable temperature inside a warehouse using, traditional heating methods, very costly and very expensive and very hard to do. Where with this system, we're using the sun's natural energy, creating that warm air and bringing that in with some simple louvers and fans and some simple ductwork. We can also incorporate these transpired solar collectors into architectural design elements. Here you can see a building that would be completely cladded with insulated metal panels. The silver panels would be decorative Rainscreen panels, but the darker panels are all of that transpired solar collector. And that is trapping and bringing air into the building and preheating it before it goes into the HVAC system. So a lot of design and a lot of performance using these components. Last but not least, as we're finishing up our presentation, insulated metal panels are great contributors to gaining LEED credits. We know when trying to build to LEED standards can be often great difficulty with it, but insulated metal panels help contribute in 7 potential areas. We won't spend a lot of time on these areas, but the purpose is to show you that insulated metal panels, there is a lot of options that can help contribute to increasing the LEED points needed. So once again, a lot of categories that insulated metal panel barrier backup systems can help contribute. So in summary, when creating a building, we have to create that perfect wall. Insulated metal panels are an excellent choice to do that because all of those primary control layers are built into a single component. There's fewer components when we look at a robust Rainscreen system, which typically has 8 to 9 different components. We can pull that down to about 5 different components with a barrier backup system. There's a wide variety of facades that can be used on the Rainscreen portion of the system. The architectural flexibility, mixed use of materials, and then of course that accelerated installation time, really making the barrier backup system a very viable and architectural and thermally efficient system. So that would conclude today's presentation. I really appreciate everyone being involved and coming here today, and thank you. If you have any questions, please feel free to reach out to ATES. We would like to support you on any type of project or answer any of the questions that you may have.
Awesome. Thank you so much, RC. That was a great presentation. I do see that there were a lot of questions that came in, but it looks like Jason was super on top of it and has answered most of them. So yeah, we've got a few more moments, so we'll give a final call. If you've got any questions that you haven't submitted yet, feel free to do that through the Q&A now. I'll also mention as you're heading out from today's webinar, there will be a quick post-event survey. If you've got any questions that come to you as you're leaving, feel free to leave them there, as well as any comments or feedback about how this webinar was for you.
One question, RC, that came up that I thought would bear a little bit of conversation at the end here came from Sarah, and she asked, how is the performance of the joints between panels maintained over time? So can you perhaps talk a little bit about the joint details of how we handle those with insulated metal panels?
Okay, and Jason, I couldn't hear you real well, but the question's obviously related to the joint, but there was a key word that you said in there.
I can read it out loud. How is performance of joints between panels maintained over time, and how are joints detailed?
Okay, thank you. I appreciate that, Bill. All right, so the panel interlocks, they are a offset tongue and groove system. When the panels are installed onto the wall system, the first panel would be installed, and there's going to be clips and fasteners that are going to install. The next panel is going to slide in place, engaging that tongue and groove, and then it is fastened to the wall. Within that panel joint there, and I will see if I can go back here on the screen, pull up that panel interlock here. Give me 1 second. There we go. So you can see, and each manufacturer is a little different, but you can see that tongue and groove design there. Now, this is kind of exploded a little bit. So you can kind of see the two panels engaging. The blue area is a panel clip that acts as a bearing plate, and then you have that fastener. But these joints would be typically tightly flushed together, making insulation to insulation contact. The vapor and air barriers are built in there, which would prevent any type of moisture into the building. But these panels would be flush, so the insulation would be touching. And you can see, if you look closely, the facer skins and the liner skins never touch. So all the panels are thermally broken, which is going to allow for that continuous insulation and also limit the amount of transfer that we would have.
Awesome. All right, great. We've got a few more minutes. It looks like Jason is typing in an answer to this, but maybe we can get to it out loud as well. Marco asks if you know if IMP have been used in passive house projects, and do you have any information on those types of projects?
Okay, so and Bill, you might be able to help me out here. The passive house would be, is that like a net zero when we refer to like a net zero building?
Yeah, I think that's pretty in line.
Okay, so I personally haven't been involved that I know of any. A couple of the benefits with the insulated metal panels is that high R value associated with them. The building that I used an example of this presentation, that middle school there, the energy efficiency that they've seen, they can actually go days without using the boiler system because the system is so energy efficient. And I believe the architect, who's local to the greater Philadelphia area, is actually doing a study right now of the energy performance of it. So when it comes to energy conservation, thermal performance of the building, and the overall comfort of the building, yeah, I mean it's we're basically making a building that's a large cooler. One of the most common applications for insulated metal panels are cold storage or refrigerated buildings because of the energy performance and the high R value. So any type of building that where you're really looking for accelerated energy performance, insulated metal panels would be a great choice.
All right, awesome. Well, it looks like we've gotten through all of our open questions then. Oh, one more while we've got 1 minute. This should be quick. How long is a typical panel lifespan?
Okay, so we talked about many of those panels, the original systems of insulated metal panels being produced in the 1960s. Like I said, the concept of the panels hasn't really changed, while the performance of them have. Many of those systems are actually still in place. So in summary, when these panels were first created, those first buildings that were used with them. Many of them are still in place today.
Awesome. All right, with that, looks like we are about ready to wrap up today. So just want to thank everyone in the audience so much for joining today and for asking such great questions. And thank you, RC, for an excellent presentation, and Jason for being online and helping us out with all those answers.
Thank you so much, everybody.
Thank you, guys.
Thanks, everyone. Have a good one.
Thank you.